Okay, class 11. With this video, we are going to start one of the most important topics that you'll deal with in class 11, which is vectors. This particular topic involves a lot of mathematics. In fact, to do physics, you need a lot of mathematics. All right, so you have to sharpen up your mathematics skills. Remember, okay. Now, the things that you study in this particular topic, okay, we will need a lot of those in the other topics that are going to follow. All right, also in class 12. Okay, so that is why this topic is very, very important. Remember, a lot of things that you study in here will be needed. All right, so let us start with this topic, vectors. Okay, you are very familiar, I believe, with the definition. Vectors are physical quantities having both magnitude and direction. Of course, I have not written the examples of vectors. All right, you will write it yourself, of course. Now, a vector geometrically is represented by an arrow. Okay, where remember, the length of the arrow gives us an idea about the magnitude of the vector, and the direction, the idea about the direction, is given by the arrowhead. Okay, so so to say, if this is, say for example, a force of 4 Newton, this arrow represents a force of 4 Newton, then almost half, okay, I have not measured it exactly, okay, but almost half of this vector has to be a force of 2 Newton, and for convenience I have shown this vector, this force, also to be in the same direction. All right, so this is what we mean, what we understand by the length gives us an idea about the magnitude of the vector. Okay, 2 Newton is half of 4 Newton, so therefore this arrow is almost half of this particular arrow. All right, that is exactly what I've written over here. You can read this. Okay, the length of the arrow gives us an idea about the magnitude of the vector. The arrowhead gives us an idea about the direction. Now, the notation that we use for a vector, okay, the symbol or the symbolic representation of a vector is this. Okay, either a capital letter or a small letter. It could be A, B, C, D, whatever. All right, with an arrow above it. Okay, you can say a half arrow above it. Okay, so this represents a vector A, vector whose name is A, some vector A. Okay, and another notation that you will see is the vector itself in between two vertical parallel lines. Now, this vertical parallel lines, this actually is a mathematical notation, mathematical symbol. Okay, I don't know whether you are familiar with this or not. It's called modulus, whose plural is moduli. Okay, this modulus, like I already mentioned, is a mathematical symbol. Now, whenever you see a vector inside the modulus sign, okay, this notation represents only the magnitude part of a vector, remember. Okay, we know vector has two parts. One is the magnitude, the other is the direction. Okay, so whenever you see this notation, we are only speaking about the magnitude of the vector in that case, remember. Okay, so some important points that you need to remember. Okay, it's not going to be asked in the exam, of course, all right, but you will need to remember this. Not all things that have magnitude and directions, okay, can be considered or can be a vector. Like, for example, electric current. Say, for example, I have a wire, okay, through which electric current is flowing in this direction. Electric current I is flowing in this direction. So I is the magnitude of the current. Okay, it has a certain direction C, but still remember, electric current is not a vector. All right, because for things which have magnitude and direction to be considered a vector, okay, they have to obey something called the rules of vector addition. Now, we are going to talk about vector addition in the next video. Okay, but remember, they have to abide by the rules of vector addition. Only when things having magnitude and direction abide by the rules of vector addition, then that particular thing can be considered a vector. Remember that. Okay, we are, like I mentioned, we are going to talk about rules or laws of vector addition in the next video. Since electric current does not comply with the rules of vector addition, so therefore, although it has magnitude and direction, it cannot be considered a vector. Okay, so these two are points that you need to remember. All right. Okay, so since today today's video is the introductory video about things related to vectors, okay, vectors in general. So therefore some definitions. Now, null vector. What is a null? Means something that's not there, okay, zero. Null means zero. So therefore, as the name suggests, a vector having zero magnitude and no direction is called a null vector, okay. Like for example, I have a force of 2 Newton in this direction, all right. I have a force of again 2 Newton but in the opposite direction, okay. So two equal and opposite forces acting at a certain point, all right. So what will be the sum of these two vectors? The sum of these two vectors will be 0, okay. In fact, this will be a vector, this will be a 0 vector, okay. So the result that we are getting, the sum that we are getting when you add, okay, two equal and opposite vectors is 0. So this particular vector is what is called a null vector, remember, okay. So vector having 0 magnitude and no direction is what is called a null vector. Another thing is equal vectors. Very important for you to understand equal vectors. Two or more vectors having the same magnitude and the same direction are called equal vectors, okay. For two or more vectors, let's say two vectors, for two vectors to be considered to be equal vectors, they have to have the same magnitude, of course. They also need to have the same direction, remember that. So I haven't used a ruler, of course, to draw these lines, okay. So I have a force. Again, I'm giving only examples of forces. There are other vectors also, other examples of vectors also. So a vector of 2 Newton, a force of 2 Newton, another force of 2 Newton. So they have equal magnitude and they are in the same direction. So these two are equal vectors, remember. Likewise, these two are equal vectors. They have the same direction, they have the same magnitude. These two vectors, this vector has magnitude 2 Newton, is directed towards my right hand side, okay. Although you can't see my right hand, anyway, this vector here, this vector again of 2 Newton but directed towards the left, okay. So therefore these two are not equal vectors, although they have the same magnitude, but they have opposite directions, okay. So they have different directions, they are not equal vectors. Likewise, these two vectors, although they have the same magnitude, they have different directions, so therefore they are not equal vectors, okay. Another very important thing, we are going to talk about this in the videos to follow, okay. Very important, but for now just look at the definition. Unit vector, unit means 1, okay. So a vector having magnitude 1 is what is called a unit vector. A vector having unit magnitude is called a unit vector. But of course, this vector, although having unit magnitude, also all vectors having unit magnitude are called unit vectors, remember. Although they have unit vectors, they will have some direction, okay. So therefore, unit vectors, they give us an idea about the direction of the vector, okay. So this thing unit vector will have a certain direction, so therefore it will only give us an idea. It will have unit magnitude, okay. So it will give us an idea about in which direction the vector is directed, all right. So understand only this much for now, okay. We are going to talk about this thing more in the videos to follow, all right. Now the symbol for a unit vector, a with I call this a cap, okay. So a cap, or it could be also in small letter, or it could be any letter, remember, of your choice, okay. So a cap, this, wherever you see this cap, you have to understand this is a unit vector, all right. So since a vector has two parts, a magnitude and a direction part, so therefore this vector a can be written as its magnitude, okay. The vector itself inside the modulus sign means this is only the magnitude part and this is the direction. Remember, unit vectors give us an idea about the direction of the vector, okay. In which direction that particular vector is directed, it is given by a unit vector, okay. So a vector on the whole can be represented by the magnitude part and its direction part. Thereby, unit vector is written as the vector itself divided by its magnitude. So this is the mathematical part, how to calculate unit vectors. We will do problems on calculation of unit vectors, okay, but that is for another video. Okay, so remember, this is the definition of unit vector. Unit vector is, this is a mathematical definition of unit vector. Unit vector is the vector itself divided by its modulus. Okay, divided by its magnitude, so to say. All right. So pay attention to all of these things that we've written. Okay, I hope you all are making notes for different things that we're discussing in different videos. All right, so this much for this video. In the next video, we are going to discuss about addition of vectors, or rules for addition of vectors. All right, so thank you. Stay safe.